Hello, geometry class, and welcome to this video that is meant to help you go through the 5 exercises that I gave you from the textbook to prepare for your assessment on sections 11.1 through 11.5. So if you want, you can pause the video here, check your answers, but we're going to go on. We're going to go through each one of these and see where the answers come from. In number 5, we were given a parallelogram whose length is 12 and whose width is 8, and the included angle is 60 degrees. Now, we actually have a formula that says that the area is equal to the length times the width times the sine of the angle between them. And that'll work here. However, just understand that when you use if you use a calculator for the sine of 60, you get a decimal of 0.8660. And if you plug that in, you're going to give me a decimal in return. And that's not what I'm looking for. Nowhere in here does it say round to the nearest 10th or 100th. So then how are you actually supposed to solve it? Well, the textbook is expecting you to draw in a right triangle and create a 30, 60, 90 right triangle. So the sine of 60, yes, it's 0.8660 if you round to the nearest 4 decimal places. But the sine of 60 is really the square root of 3 over 2. And that comes from the 30, 60, 90 triangle. Now, if the hypotenuse is 8, the small side is 4, and that means that the height of the parallelogram, if the base is 12, is going to be 4 rad 3. So my area is going to be the base, 12, times the height, 4 rad 3, which gets me 48 times the square root of 3. That's my final answer. Okay, 17 and 20, they're asking us to find the area of 2 triangles. Number 17, the triangle is isosceles, and we're given the 3 sides of 41, 41, and 18. Later on in the chapter, we're going to learn something called Hero's formula or Heron's formula, which will allow us to find the area of a triangle just by using the 3 sides. But that won't work here because we haven't seen it yet. So what do we do instead? Well, we drop in the height to a base of 18. You notice that, yes, it's an altitude, but since the triangle is isosceles, it's also a median. It's a perpendicular bisector. So that means that this base gets cut in half, and each of those sides is 9. And I've created a right triangle. And in fact, it's a Pythagorean triple. It's a 9, 40, 41 right triangle. So now I can say that the area of the isosceles triangle is 1/2 times the base, which is 18. And don't forget that it's 18. Don't just put 9. It's the entire base, which is 18, times the height, which is 40. And half of 18 is 9. 9 times 40 is 360. And that's where we get our answer. In number 20, here we have an equilateral triangle with a perimeter of 7. Yes, this is a regular polygon, so we could use 1/2 AP, but that's a waste of time. We also could drop in the altitude here and use 30, 60, 90 triangles. However, there is a formula for the area of an equilateral triangle. It's actually right in your textbook. It is s squared times rad 3 over 4, where s is the side length. And where does that formula come from? Well, it comes from getting this height from 30, 60, 90 triangles. So it's not that difficult to derive. Okay, so my side length is 7. So it's 7 squared, which is 49, times the square root of 3 over 4. You saw my answers that I did 49 over 4 is 12.25. You don't have to do that. You're perfectly fine if you leave it as 49 rad 3 over 4. Okay, the next 2 problems are a little bit more challenging, a little bit more fun. Now, here we're given a regular hexagon whose span is 36. And if you're sitting there thinking, well, what's a span? It's right there in the diagram, okay? Don't overthink it. The span is the length of that diagonal. Now, if you look at that triangle, yes, it's isosceles. The vertex angle is 120, and we've seen this diagram enough to know that the ratio of sides is x, x, and x rad 3. And if you're thinking, have we done this before? Like, well, of course we have. You just need to pay more attention. So you also can figure it out using 30, 60, 90 triangles, and I know you can. Now, if we're told that the span is 36, that's what x rad 3 is. X rad 3 is 36. Okay, so what's x? Well, let's divide both sides by rad 3 to figure that out. If I divide by rad 3 and then multiply by rad 3 over rad 3, then I get 36 rad 3 over 3, which is 12 rad 3. Okay, so 12 rad 3 is the length of my side. I still can use 1/2 AP since it's a regular polygon, But we also have a special formula for hexagons, and that is the area is equal to 3 times the side length squared times rad 3 all over 2. And you can derive that from looking at a regular hexagon as 6 equilateral triangles, finding the area of each triangle and multiplying it by 6. Okay, now the side length we know is 12 rad 3, so we're going to get 3 times 12 rad 3 squared times another rad 3 all over 2. What's that? Well, when I square this, I'm going to get 3 times, don't forget to distribute to the 12, 144, times rad 3 squared is another 3 times rad 3 over 2. And 3 times 3 is 9 times 144 is 1296. Cut that in half and you get 648 rad 3. And that's my final answer. Okay, the last question gives us an isosceles trapezoid whose smaller base is 2, the perimeter is 70, and the acute base angles are 60 degrees. So find the area of the trapezoid. Okay, well, we're going to need to know what the second base is down here, and we're going to need to know what the height is. Okay, they're telling us that the perimeter is 70, so let's mark some of the sides. I don't know what the legs are. Let's call them X. And when I draw in this other altitude, this is 2, and then I have these two parts right here, which have to be equal to each other, but I don't quite know what they are, and I'd rather not introduce a new variable if I don't have to. And it turns out I don't, because the base angle was 60 degrees, and that is a 30, 60, 90 right triangle. The hypotenuse is x, which means that this is half of x, and there's another half of x. So now, if I wanted to set up an equation using the fact that the perimeter is 70, I can say that 2 plus x plus half x plus another 2 plus another half x plus another x is equal to 70. So altogether, that is 1, 2, 2.5, 3 x's plus 2 and 2 is 4 is 70. So when I solve that, I get x is 22. Okay, so now my trapezoid looks like this. I have my legs are 22, and this is 11 and 11, and that's 2. And the height is going to be 11 rad 3. So now my area is going to be equal to 1/2 base 1, which is 2, plus base 2, which is 22 and 2 is 24, times the height, which is 11 rad 3. Half of 26 is 13. 13 times 11 is 143. So I get 143 rad 3, and that's my final answer.